Yeah. So next session, so we will move to another technology. Actually, we spoke about it in last edition, and in data centers, and we have to actually we face challenges with the heat. So cooling is very important, and sometimes also dust is very important. But there is a technology that it's emerging. We can see it as a solution for our region, for African markets or for African countries, and we welcome Mr. Franco from Submer to share with us his his insights and his experience with liquid cooling.
Thank you, Syed.
Yeah.
Okay, this is very marketing things, but I'm going to talk about immersion cooling. That is part of the liquid cooling technologies. So I'm going to divide the presentation in 3 parts. We're going to have the main challenges that we're seeing in the data center market. Then we're going to talk about the different cooling technologies that we have in the market, mainly 2, air cooling and liquid cooling. And then we're going to see the benefits that you have with immersion cooling technologies. So what are the main challenges that we see in the data center market now? Number 1 is the CPU and GPU TDPs. TDPs stands for the thermal design power that you have in the CPUs and the GPUs. So I was talking with my friends from Libya there, and they have racks of 5-6 kilowatts. But then I was talking with Martin about the data centers that they are building now in Finland, and they're using the B100 GPUs from NVIDIA, where they have 40 kilowatts more or less. So TDP is basically the watts that each CPU and GPU has, and that's increasing massively. In the past, we were talking about CPUs of 50 watts. Now with the B100, we're talking about more than 1,000 watts just in one GPU. And in immersion cooling, you can have more than 4 or 8 GPUs in the servers. Number 2, and this is one of the main problems that we have here in Africa, is access to the land and power. Power is very important, first because you need to have availability of power, but then when you have mission critical deployments, it is really important the reliability of that grid, so the quality that you have. Number 3 is the water consumption. There are a lot of studies that talk about the water consumption that each query that goes to ChatGPT is consuming. And it is important to understand there are 2 types of water consumption. You have the direct water consumption, that is basically the one related to the cooling system that you have in your data center, and the indirect water consumption that is related to the power grid. So there are some power grids that needs to consume some water. So when you measure the whole water consumption in your data center, you need to consider the direct and the indirect water consumption. Number 4 is the environmental conditions, and this one applies to Northern Africa mainly. Tomorrow I'm going to go to Egypt, where I don't know if you know about the term PUE, that is the power usage effectiveness, that is basically the ratio between the total consumption in your data center and the IT consumption. So they have a PUE of 2, which means that per each 1,000 watts of ICT, they need 1,000 watts more for the electrical and the mechanical infrastructure. The goal with this client is that we want to reduce the PUE to 1.3, 1.4. So the challenge is the weather conditions that you have, the temperatures that you can have in Egypt. We're talking about 50, 55 degrees Celsius. And you have a data center that requires temperatures of 20, 24 degrees Celsius, cold air. So you need to gather that type of information in your data center. And the last topic that is really important in Africa is the increasing data demand. As we know, digitalization in Africa is taking more time than the one that we have in Europe and America, but it's coming. And that means that you want to have more data, so more ICT, hence you need to have more powerful data centers in the market. When we go to immersion cooling, we're tackling 3 of these topics. Number 1, the TDPs of the data centers, of the GPUs and CPUs, water consumption, and then deploying this type of solutions in really challenging environmental conditions. And we're going to see why. So first of all, what you see here, it's a chart coming from Ashrai. And what it's telling you is that between 75 to 250 watts, it is okay to use air cooling in your data center. But from 250 watts up to 700, 1000 watts, it is recommended to go to liquid cooling. Martin told me that yes, they're using right now GPU servers from NVIDIA using air cooling, and you can do it. But the thing is that the space that you need just to deploy 40 kilowatts, 50 kilowatts, it's too much compared to using liquid cooling technologies. And what we have here is the roadmap that is coming from the different, what we call silicon vendors. I'm talking about AMD, I'm talking about NVIDIA, and Intel. So you can see that, well, probably you don't see it, but just AMD CPUs have more or less 400 watts CPUs. And when we go to NVIDIA, we're talking about more than 500 to 1000 watts. That means that liquid cooling is starting to be mandatory in your data center if you want to have an efficient deployment. And the last thing about the PUE. So PUE, as I told you, power usage effectiveness, the ratio between the total consumption of your data center and the IT consumption. Best case scenario, probably in countries such as Finland or in the Nordics, you might be able to have a PUE of 1.3, 1.2. But when you go to immersion cooling, we can reach a PUE of 1.1. And when we talk about the partial PUE that is related to the cooling system, we can go to 1.03. So how do we achieve this? First of all, two types of technologies in the market. We have air cooling, and then we have liquid cooling. Air cooling, we have different configurations. We have the cold air, we have the cold air. We also have the cry units. We can have the cracky units. This technology, we keep using it, but we're reaching a point where you're gonna need to go to this type of solutions that we call liquid cooling. And in liquid cooling, you have three main technologies. You have DLC, direct liquid cooling or direct to chip. Number two, single phase immersion cooling. That's what we do in Submer. And then two-phase immersion cooling. So I'm going to start with two-phase immersion cooling because it is a technology that is having, let's say, a big challenge right now. Two-phase immersion cooling, similar to immersion cooling, you put the server inside a fluid, a dielectric fluid. But the thing in this technology is that the fluid changes phases. It changes from liquid to gas, and in that way, they dissipate the heat. The challenge that they have is that they use PFAS fluids. I don't know if you know about PFAS, but the PFAS are also named forever chemicals, and they are toxic for people and the environment. So for that reason, you see that these type of fire agents like FN200 or Novec are being banished from Europe and America. So it is a similar fluid. So for that reason, they're starting to change the type of fluid that they use. So far as I know, they haven't found a fluid that they can use. Direct liquid cooling, so DLC. They focus in the component that generates more heat in the server. That is the chip, CPU or GPU. So what they do is that they bring a cold water loop through a manifold, and then that manifold is connected to small pipes that goes to the servers and dissipate the heat of the CPU and the GPU. As I told you, that's 70% of the total heat that you will have in your server. The other 30%, you need to use another water loop to generate cold air to dissipate that heat. So you have two different water loops working in this solution. One of the challenges that they might have with this technology is that you have a lockdown to the server vendor. So for instance, Lenovo is offering this type of solutions. The challenge here is that if you go with Lenovo, then you won't be able to use a Dell server or an HP server because the design of the manifold and the rack is specifically per each vendor, and they don't have a unified standard that they can use. And then you have immersion cooling single phase. That's what we do at Submer. So before explaining how the technology works, let's see what are the main components. So you have the tank where you have the fluid and the servers. It is a dielectric fluid with 15 years lifespan. Then you have the CDU, that is the cooling distribution unit. Basically, it is a heat exchanger with two pumps. And then you have the water loop, similar to the one that you have in an air-cooled data center. In this technology, we have three heat transfers. The first one is from the server to the dielectric fluid. The second one happens in the CDU, cooling distribution unit, that is from the fluid to the water loop. And the last one is from the water loop to the ambient. So what makes immersion cooling difference? Probably you don't see, but this is the data hole, and here you have the tanks. The biggest difference with immersion cooling and other technologies, it is the water temperatures that we have in our water loop. In a standard air-cooled data center, you might have 16 degrees Celsius. I think that you have 16. So if you have 16 degrees Celsius in a water loop to generate cold air, then you're going to need to have a really big chiller in your system. So from a CapEx point of view, that's going to be a lot of money. But the other thing is also the consumption. The electrical consumption in a chiller is really big, basically because they're using compressors. In the case of immersion cooling, you can have temperatures of 40 degrees Celsius. This means that you're going to be able to have what we call free cooling. Free cooling means that you just use the environmental conditions to generate the cold water that you need in the data center. So in countries such as European countries and also in the Nordics, you're going to be able to have free cooling the whole year just using this type of technologies. In the case of Northern Africa, obtaining free cooling is kind of hard. This client that I'm going to visit tomorrow in Egypt, they would love to have free cooling, but that's impossible when you have temperatures of 50 degrees Celsius in the environment. But you can have at least 8 months of free cooling. So that's one of the advantages that you see with immersion cooling. And with this, we can talk about the impact that we can have using this type of technologies. So number one, as I told you in the previous slide, is the TCO. When you use immersion cooling, you're going to be able to reduce the cost in your data center. Number one, because the CapEx. You're going to have a simpler cooling system. Number one, if you compare it to DLC, in direct to chip or direct liquid cooling, you have 2 barrel circuits going to the data center and to the data hole. In the case of immersion cooling, you just have one water loop. In Barcelona, we have the Barcelona Supercomputing Center. It's an HPC node, and they are using 3 water loops for the racks. One that is for DLC, 2 that is for the rear door heat exchangers, and another one that is for the comfort. So in the end, you have 3 different water loops that you use, which increase the CapEx when you're basically constructing the data center. The other topic is the water consumption and energy consumption. When you improve the PUE of your data center, you're going to be able to reduce basically all the costs that you monthly paid for the usage of your ICT and your cooling components. Number 2, higher revenue per square meter. Obviously, this will depend on the flexibility that you have to obtain more power in your data center and also the capacity to retrofit the data center. But we can increase the ICT load that you have in your data center if you change from air cooling to immersion cooling. Basically, our solution, we can have more than 300 kilowatts in a 41U rack. So that's one big advantage that you can have using immersion cooling. On the other hand, you can be more sustainable. So basically, when you increase the PUE, you're reducing also your carbon footprint in your data center. It's important to know that the fluid that we use is biodegradable. So there are 2 types. We have the mineral-based fluids coming from companies such as Castro BP, Shell, Total Energies, but also we can use bio-based fluids. On the other hand, and this is something that we also discuss with our clients, is the operational resiliency and reliability. So normally when people think about immersion cooling, they think that it's going to be hard to operate this type of technologies. But in the end, it's similar to a standard air-cooled rack because it is a tank that is similar to a 41U rack. And you have different accessories that you can use. On the other hand, there is a big ecosystem around immersion cooling. So there are different server vendors already offering solutions for immersion, such as Supermicro, Gigabyte, and 2CRSI. And the last thing is that this can be a differentiator for your business. This client that I'm going to visit tomorrow in Egypt, basically one of the reasons that you're using immersion cooling is number 1, because they have a net zero goal. And for that reason, they want to find ways to increase or to reduce the PUE that they have in the data center. And number 2, because it is a differentiator for them in their business when they have all these competitors looking also to have more sustainable solutions. So when they use immersion cooling, it's a different way to find the same goals that their competitors are having. And with that, I think that it's ready. So I don't know if you have any question for me.
Yeah, hello. One question, and you also mentioned it, that Supermicro and Gigabyte are having this type of cooling. If I go to another vendor and I want to have a warranty on my components, and they say, okay, we put it in the dielectric fluid, you lost your warranty because we don't support that. How is that going?
Yeah, so that's a good question. There are two types of, let's say, ICT that you can use in immersion. You have the immersion ready ones. So there are companies already offering that, such as Supermicro, Gigabyte, and other companies such as Dell or HPE. What they do is that they use let's say, an official partner that is capable to retrofit the server for immersion, and that company is going to be the one offering the warranties. Because in the end, an air-cooled server, you won't be able to use it in immersion. So you need to make some changes. You need to disable the fan. You need to update the firmware. So there are specific companies. One of them is Unicom, that they can offer that type of solutions. Dell, HPE, they use this company to retrofit the servers.
Okay, clear. Thank you.
No more questions?
Yes. Hi. You must have calculations on how much cooling capex is reduced by taking this immersion system on site.
So is your question about the price of our technology?
Well, yeah, the cost of you were saying that you can reduce your capex on the cooling systems, CRAS and etc. etc.
Got it. I mean, I can share with you prices privately after we sign an NDA, but
absolutely.
Let's go back to this page here. I guess that you know what is a chiller, what is a dry cooler.
Mm-hmm.
So one important thing here is that you have 40 degrees Celsius. This temperature that you see here is basically related to the type of load that you have in your tank. So the more kilowatts you have in the tank, the colder the water temperature. And then you have the set point. The set point is basically at which temperature is the tank working. The colder it is, the colder also your water temperature. But in general, the water temperatures are going to be higher than 30 degrees Celsius. So that means that instead of using a chiller, you will use a dry cooler. A dry cooler is basically a group of fans. So this dry cooler with the same power capacity might be 3 times cheaper than the one that you use in a standard chiller. And on the other hand, you're not using the CRAC units. You're not using the CRAC units. You're just going directly to the tank. Okay? But then I can share with you some more specific prices so we can discuss about it.
As another technological issue about cooling, for example, when we have, let's say, electricity or some energy and would like to heat something, we just easily heat it. But for example, if we would like to make it colder, like refrigerator, we also need to use energy to make it colder. And technologically, it's like some, gap here. So should be some technological solution. Because if we have as energy, we can convert this energy to heat. But if we have heat, technologically should be a way how to make it colder and get energy back. And the question is because it's in physics, it's really gap because there are no solution for this. But what do you think about future? Because it will be very logical. So you can heat something, spend energy and heat and make it hotter. Well, should be opposite, yeah. So you make it colder and get energy back.
I mean, it is a good question, and I'm going to redirect you to what the market is doing right now, specifically in countries such as Lithuania and in the Nordics. In some cases, instead of having a dry cooler or a chiller, you will have a heat exchanger, and then you can use the heat generated in the data center for another application. So it's what they call heat reuse or heat recovery. So in that way, because in the end, you are going to always dissipate the heat to the ambient. So the only way that you have to not dissipate the heat to the ambient is basically changing that dry cooler for a heat recovery application such as district heat. So that's a way that you can reuse this type of technologies. And by the way, this is something happening not only with immersion, but also with air cooling and DLC. You always need to dissipate the heat to the ambient or to a heat recovery application. Obviously, heat recovery will be able to have it when you have cold temperatures. Having heat recovery in Tunisia probably is going to be hard. maybe something in winter, but in general, you won't be able to reuse that heat for other applications because it's already warm. So I don't know if this answered your question.
Is there no maybe right answer to the question not exist possibly, but something about this? Yeah, thank you.
Yeah, probably you're talking about the heat pumps that sometimes they use this hot environment to generate cold. But that's another type of heat recovery application that you can have in your data center. Okay?
Yeah, thank you.
You're welcome. I think that there was a question here.
Wait. This is all superficial.
I had two questions. The first of them, what is regarding a certain configuration, Southern Europe or Northern Tunisia, the break point in terms of surface or capacity of that center, where it's profitable to switch from normal air cooling to immersion air cooling. Is there a break point? Define the break point. In Africa, we have little data center.
Yeah.
The size of data center is so. One operator will think, will it be profitable for me regarding the size of my data center to invest in that technology? Okay. The second question is it wasn't clear for me, or it's yes, no. Do we need air conditioning for the ambient if we have immersion? Yes or no?
Okay. So let's start with the second question. The answer is no. You don't need to have you don't need to use cold air for the data hall. I mean, if you want to have it, it is for the comfort of the people operating the data center. But probably 98, 99% of the heat that is generated in the servers keeps in the fluid. So you are dissipating the heat from the fluid to the water loop, 100%. In the case of DLC, direct liquid cooling, that is another type of liquid cooling technology, there you need to use two water loops, one for cold air and another one for the DLC solutions. Then for your question that you're talking about, what is the kilowatts that means that I need to switch to immersion cooling? And my answer always to that question is it depends on the type of business that you have. Because in the past, we used to think about immersion cooling just for high power density, AI, so more than 100 kilowatts. But think about it, because if I have 100 kilowatts here, I'm going to need to have colder water than if I have 50 kilowatts. So the main driver of this client that I have in Egypt that I'm going to visit tomorrow is not because they have a really high power density solution here. It's because they want to improve the PUE. So working with 40 kilowatts, that is not really dense, you're going to be able to work with 35 degrees Celsius, 40 degrees Celsius, and they're going to improve the PUE and also the carbon footprint that they have so they can meet the sustainability goals that they have for 2040. So normally, if you want to have a number, probably more than 20 kilowatts, you can start thinking about immersion cooling. Obviously, there is a CapEx discussion here. But yeah, main driver will depend on the type of business that you're looking for. Normally, what I have seen is that they want to use more than 20 kilowatts per rack. But the thing here is,
I have an infrastructure, I have data center, and I have a big consumption. And let me say that we have a size of 1 megabyte or 1 megawatt. Will it be profitable for me to switch regarding the investment in the cooling system, investment in retrofit of
data centers
of the server themselves?
Yeah,
there's a capex investment.
Yeah.
So there will be break point. Will it be at 1 megawatt, at 2 megawatt, at 10 megawatt, at 20 megawatt?
Yeah. I mean, from that point of view, it depends. But I can tell you that the projects that I'm working with, at least the minimum value is 500 kilowatts. I'm not working in projects less than 500 kilowatts. The only thing is that before they're doing the switch from air cooling to immersion cooling, they always start with a POC. But you can have different, let's say, business models that you want to follow. You might have a data center of 300 kilowatts with 40 racks that you can replace that with basically 3 racks, 3 tanks of 100 kilowatts each of them. And in that way, you're saving a lot of space. And then you can use that space to have more tanks and more power. But do you have the power availability to increase from 300 to 600 kilowatts? So that's the thing. And the other topic is, what type of ICT are you going to use? Are you having, I don't know, an interface as a service product where you can share the server that you're using per each client? So it depends a lot in the business model that you have. But I can tell you that the projects that I'm working are more than 500 kilowatts. Okay? So I don't know if this answered your question. Yep. Good. Any other question? Okay, thank you very much.
Yeah. Thank you, Franco. But one comment, Franco. If we sign an NDA, the value of the price or the value of the information of the price, the information about the price, it doesn't have any value. So if you don't speak about the price, it doesn't make sense. Yeah, but if when you give a price, maybe it's high for people, but maybe it's an anchor. Okay, it's affordable. Why not?
Yeah.
No, because we heard about the NDA, I think 2 times. It was, yeah. Yeah.
No, yeah, I mean, we can talk about prices.
Because we don't know how much it costs. Okay, we can, wow, great technology, but can I afford this technology? Can I? No. You know, That's why we need to have an idea, you know.
The thing is that
even for business development perspective, we have here several business developers.
Yeah. Yeah, but the thing is, what is expensive and what are you taking into account? Because in the end, you have the tank, that is our part. But then you have all the mechanical infrastructure, and you need to analyze that too, because probably you're going to have some benefits on that side. That doesn't mean that our solution is expensive, because it is not. But I can tell you that you need to take into account different pieces.
Yeah. You know, in cloud computing, we always speak about total cost of ownership. And we speak about it. You don't need to compare hardware, software, and blah, blah, blah. You need to take in consideration the high availability and the cost of the down time and everything. Yeah. But it's still not $1 or euro. So that an architect like Elias or Fatma, they can consider it in designing a data center.
And I have no clue. Since I'm not into this hardware AI, if we talk about 50K, 500K, no idea, you know. And if you have a rough number, we can also think about how long it takes for the return on investment.
Yeah. I mean, I can tell you that the price of our solution is probably
huge pressure.
Less than 10%.
We want to have a price.
Of the price of what you have in the servers in the tank. I mean, in a solution that you can talk with Martin about it, but you can have $2 million, $3 million in just 42 use, or $1 million. So it depends on the... Sorry, what? It depends. There are 2 types of solutions. You have retrofitted servers and immersion-ready servers. So in the case of retrofitted servers, obviously you need to add the price of retrofitting the server.
But at the same time, you can replace investing in other equipment that costs the same amount, you know? This cooling system.
Exactly, but you're talking about the CapEx. But then we have the OpEx. So all the savings in energy and water that you will have in that data center in 5-10 years.
Yeah.
I made one study for a company in Greece where we saw that the break-even was around 4 years compared to air-cooled solutions. But again, it also depends on the environmental conditions that you have in that environment. Obviously, the hotter, the better for us to see the benefits of immersion cooling.
Yes, definitely. Yeah. Thank you.
Thank you.
So now